To talk about polynomial operations. So today we will do addition, subtraction, multiplication. Division's a little bit harder. We'll save it for its own day. You ready? Yes, Miss McKee. Okay then. Let's talk. Thank you. Let's talk about addition first. Addition and subtraction kind of go hand in hand. First off, what's a polynomial? Do we know? It's a polynomial. Yes. Polynomial has one or more terms. Terms meaning things like 2x or 5x squared or 1/2 x to the 5th. All of those are terms, okay? So one or more terms, and all of the exponents that are hooked to x are positive whole numbers. Let me give you a couple and you tell me if they're polynomials or not. Yes or no?
Yes.
Yes. Remember, are the exponents positive whole numbers? Yes. Okay. And it's one or more terms. So we're good to go. How about this one? Yes or no?
No.
No, why?
It's got a half.
That 1/2 makes it not a polynomial. So no. How about that one?
Yes.
It is actually. Well, it's got two terms. That's a constant, still a term. That's okay. And the exponents are positive whole numbers. Okay. We see where we're going with this? Okay. So we're going to add, subtract, multiply these today. Before we do, I want to talk about something for just a minute that you really already know, but I want to refresh you, make sure you know. When we talk about combining like terms, we say that a lot in here. I hear y'all say that a lot. Combine the like terms, combine the like terms. What are like terms? Tell me that. What's alike about them?
Like 5x and 2x.
Okay, like 5x and 2x. Give me another example. 4x squared and 3x squared. Give me another example. 2 and 4. Give me another example.
1/2 squared and then like 3 squared.
What is always the same on like terms?
The endings.
The endings, which are what?
Squared of x.
The variable and the exponent on the variable. That's what makes them like terms, right? It doesn't have anything to do with the number in front of x. The number in front of x has another name. The 5, the 2, the 4, the 3, the 2, the 4, the 1/2, the 3. That's called what? What are those called? Starts with a C. Coefficients. Good job. They're called coefficients. Coefficients are in front of x. I'm going to give you a second to catch up with me before I... If I want to add like terms, so let's say I take these two, and I said 4x squared plus 3x squared. We've already determined that they're like terms. How do you combine the like terms? What do? You add the coefficients, the numbers in front. You're exactly right. So to combine like terms, I'm only going to combine, and this is very important, you might want to start. Combine the coefficients, but we leave the variable and exponent alone. So 4x squared plus 3x squared becomes what? 7x squared. Does that confuse anybody? We're going to take this concept and apply it to polynomials, okay? So let's talk about addition of polynomials now. Addition of polynomials. Let's say I have 3x to the third plus 6x squared minus 5x plus 2. And I want to add to that negative 5x cubed plus 2x minus 8. What do you think you need to do? Combine like terms. That's all you have to do here. All you have to do when you see that addition sign in the middle is combine like terms. Now, it's a good idea to keep your exponents in order, okay? Start with the biggest one and work your way down. So the biggest exponent here is 3. So 3x cubed goes with which other term? Negative 5x cubed. What is 3x cubed and negative 5x cubed? Negative 2x to the third. I'm done with that one, so I'm going to mark it out. What's next? Do I have any powers of 2? Look at this one. I just have that 1, so if it doesn't have one to add to it, then I'm just going to write it. And then you're exactly right. 2x and negative 5x, and I generally mark them out so I don't lose my place here. Negative 3x, and those are gone. Now what? Minus 6, because 2 and negative 8 would be minus 6. Does everybody see what we're doing? Where? Oh, that's a 2, I'm sorry. Easy enough? Addition's really easy if you can identify the like terms. That's all we do for addition.
So is that the answer?
That's the answer. Easy? You've really done it before, just not with powers bigger than 2. Remember, we're doing addition, subtraction, and multiplication. Multiplication is the hardest. You like it? Huh? Probably you have, yeah. All right, so let's subtract, because subtraction is really adding a negative, right? So it's kind of the same thing. When we subtract, let's see, I'm going to do yeah, that's a 2x. Yes, what I'm going to do for these, and this is where, and we did this with quadratics, remember, we've already done this. This is just a little bit bigger. When you subtract these, what you want to do is you want to do same. So the first set of parentheses I want to leave exactly the same. I'm going to change the middle sign. Okay, so this one in the middle. And then I'm going to change the sign of everything in the parentheses that follows. So everything in this parentheses, so I'm looking at parentheses whenever I'm talking about same, change, change. So I'm talking about same, change, change. Okay? So when I change that second set of parentheses there, it becomes negative, negative, positive, negative. Now it's an addition problem, and when I'm adding, I'm just doing what? Combining like terms. So let's get them together. 4x cubed and negative 2x cubed would be 2x cubed. I'm done with those. Hardest part about this is watching those signs. negative 6x squared and negative x squared.
It is negative 6.
Done. 3x and 10x, 13x. And negative 5 and negative 1, negative 6. Easy? Before we multiply an entire polynomial, let's talk about multiplying terms. Okay? Multiply. If I had something like 3x squared times 5x cubed, tell me what I'd do. You put them together. You add the exponents and you do what with the coefficients? Multiply them, okay? So we multiply coefficients, and this is, remember where I told you to star that other part? This is the other one that needs to be starred. Multiply coefficients, add exponents. Everybody starts getting confused when we start mixing multiplication and division, multiplication and addition, as to when you combine and when you don't combine, okay? If I'm multiplying, I multiply coefficients and add exponents. If I'm adding, I leave the exponents, but I just combine the coefficients. So this becomes 15x to the 5th, right? But of course we don't stay that easy because we're going to multiply whole polynomials. I'm going to give you, let's start easy. Start a hard one?
No.
I'll start medium. How about that? When you're multiplying polynomials, a couple things to keep in mind. These become distribute problems, okay? Every single term, everyone in the first polynomial must distribute to every term in the second polynomial. This is like a souped up foiling. Okay, you know FOIL, we take the first one to both and we take the second one to both. Now they're just a little bit bigger is the only difference. I'm going to wait and let you catch up with me. Take the first one. Multiply through. What's 2x squared times x?
What?
Multiply coefficients and add exponents. What is 2x squared times x? 2x cubed. What is 2x squared times negative 5? Negative 10x squared. Each one of these is going to have to bounce to everything in the second parentheses. Okay? Once you're done with one, mark it out so you know you're done. So I've used 2x squared. I'm good. I got 2 more to use. Are y'all following me?
So would I add a
You're just foiling it, basically. Yes, you can add a 1.
No, like would I add a 1 like you did on that one, that x? How you added a 1 and then a 1 exponent on that 3x? Would I add a 1 exponent?
If you, that helps you to see it, yes. It's always implied there.
That mean that would be, it'd be 3x to the second power?
Yes.
Oh, so I had to have 3x to the second power?
Yes. Yes. Now do the next one.
Does it get harder than that?
They might get longer. You might have more to take, but it won't get, no. Done with that one. Now negative 1. So negative 1x. What's negative 1 times negative 5? 5. Once you have multiplied through, All you have to do at that point is combine like terms.
Alright, and that 15, I minus 15 minus x is what I need to add.
Yes, negative.
Add x to that 15.
Well, yeah, you're going to add them because they're both negative. So it's going to be negative 15 and negative 1x, which is negative 16x. Like if you do on your calculator.
Why wouldn't I do it like I've done on other problems and put plus x and then go to 15 and put plus x to the 15, which would make it negative 14x.
You're not solving. You're not moving it from one side to the other. You're just putting them together. If you needed to move that x from here to here, then you would do, you're trying to do this, I think.
Yeah.
Okay, that's whenever you're crossing over an equal sign. There's not an equal sign here. So this is really like where I'm just circling what goes together and combining them. So 2x cubed, negative 7x squared, negative 16x plus 5. Does that make sense? That's the answer. That's it. Division is a whole nother day. Well, it'll take us probably 2 or 3 days to get through division. Yes. I will show you another example. You might have something that looks like this. Do not distribute that exponent.
You just write it 2 times.
Yep. This tells you how many times to multiply.
So I just do 2x times 2x times 2x.
Well, but here's the trick with multiplying. You can't do more than 2 at a time. Okay? So if I have 2x plus 1, 2x plus 1, and 2x plus 1.
You gotta solve the first 2 and then
Yep.
that one with the answer you get the first 2.
Absolutely. Good job. Only 2 at a time. I'll give you all. 2x times 2x is 4x squared. 2x times 1 is 1 times 2x. And 1 times 1. So this becomes 4x squared plus 4x plus 1. Now take it to the third one. Do you see what we did there? 2 at a time. Don't go more than 2 at a time. Your answer will be messed up. Don't come here and try to take that first 2x. Don't do boop, boop, because it's going to give you the wrong answer. All right, now let's multiply these. Take the first one. 4x squared times 2x is what? Come on, guys. What's 4x squared times 2x?
8x.
8x cubed. It's okay. That's why I told you write that down, because they get discombobulated in your head. They always do. All right, and then 4x squared times 1.
4x squared.
Done. 4x times 2x.
8x.
8x squared. 4x times 1. Done with that one. Now a 1 to everybody. 1 times 2x. And 1 times 1. Like terms. I only have 1 cube.
Oh.
What's 4x squared and 8x squared?
12x squared.
12x squared. And then 4x and 2x. And then 1. Easy enough?
Always.
Good. All right.